Let's solve the multiple choice questions on the 2022 British Physics Olympiad Intermediate Challenge. Just a little note that these are not official solutions, and please check out the website of the British Physics Olympiad. Okay, so question 1, we have some axes across here and this graph shows. Okay, now the first thing that I'm noticing on the graph is that whatever is on here on the x-axis, when that is equal to 0, there's still a value on the y-axis. So let's go through each of the options. First of all, current and potential difference for a fixed resistor. Well, that's not going to be the case, because when the current is 0, by definition, the potential difference should be 0. Kinetic energy versus velocity for a fixed mass. Once again, so for B, kinetic energy, I'm going to call it, let's call it KE, is equal to 1/2 times mv squared. So if V here is 0, the kinetic energy will also be 0. Exactly the same with pressure and volume. If the pressure is 0, then the volume of the gas will be equal to 0. So it's not A, B, or C. The correct answer will have to be D. This makes sense if we think about it. If on the y-axis we have the mass of the beaker containing water versus the volume of the water, if we remove, let's draw a little beaker across here. So this here is with the water, but if we were to remove the water, then this beaker will still have some mass, hence the answer is D. Okay, question 2. The energy transferred by electromagnetic radiation in a vacuum, such as microwaves, radio waves, etc., increases as wavelength increases. That's not true. Frequency increases. This is indeed true. So the correct answer is B. So essentially, the lower the wavelength, i.e. the higher the frequency, the higher the energy. All of the waves travel at exactly the same speed across here, so the answer cannot be C. X-rays travel at the speed of light, radio waves travel at the speed of light, microwaves travel at the speed of light, etc. And the volume is not really connected at all, because these are they do not consist of particles, and it's just energy is transferred rather than matter. Okay, let's have a look at question 3. Consider the circuit shown. And we have a few resistors. A current of 0.6 amps flows through resistor R3. The total current flowing through the battery is... Okay, this is actually quite a tricky question. So because these are in parallel branches, if we have 6 volts across the power supply, then we're going to have 6 volts across each of the individual branches. So the potential difference across this branch here will be 6 volts, and the potential difference across this parallel branch in the middle in total will be 6 volts, which means that we're going to have 3 volts across here and then 3 volts across here. Okay, well, 0.6 amps flows through here. So if we have 0.6 amps going through here, there's going to be some current that is added up to figure out the total current. Now, how much current would that be? So to figure that one out, we're going to find the current through one of those resistors, and remember, current is equal to the potential difference, which in this case is going to be 3 volts, divided by the resistance, which is just 10 amps, so that's 3 over 10, which is 0.3 amps. Therefore, the correct answer will be equal to 0.6 amps plus 0.3 amps, which is equal to 0.9 amps. Correct answer is B. Okay, next one. So for the circuit in question 3, the power dissipated by resistor R3 is. So let's have a look at the resistor R3. Okay, the same power as dissipated by resistance R1. Okay, well, power is essentially equal to IV. So this one here the resistor R3 has 0.6 amps, and we also have 6 volts, so the total power would be 0.6 multiplied by 6, so let's call it P3 will be equal to 3.6 watts. Now the power through R1 will be equal to, so the power through R1, let's call it P1, will be equal to 0.3 amps, because we found the current to be equal to 0.3 amps, and I'm going to multiply by the voltage, which across the resistor R1 is 3 volts, as we talked about, so multiply by 3, and 0.3 times 3 will just give us 0.9 watts of power. So we can see that 3.6 is actually 4 times bigger than the power dissipated in the other resistor. Therefore, the correct answer is D. Okay, question 5. We have an out-of-control rocket accelerates vertically downwards at 12 meters per second. The mass of the rocket is 8 kilograms, ignoring air resistance. What is the thrust from the rocket engine? So the rocket is basically kind of going down like this at 12 meters per second. Now let's take the acceleration due to gravity to be equal to 10. So this really means that only 2 meters per second, 2 meters per second squared, are being provided by the engine. So we can say that the acceleration from the engine is just 2 meters per second. Then we can just use force is equal to mass times acceleration. So this will be equal to 2 times 8, because our mass is 8 kilograms, which is going to give us 16 newtons. Correct answer is A. Okay, question 6. The diagram shows a coil of wire containing 2 unmagnetized soft iron rods. The iron rods are parallel to each other and they're free to move. Okay, when a current is passed through the coil, so one of the major things to notice is that as soon as we have current, there will be a magnetic field within the coil. Now this magnetic field will turn those iron rods essentially into magnets, and they're going to be placed such that a north pole is next to a north pole, or a south pole is next to a south pole, and they will repel. They need to repel due to conservation of energy, but they will repel, and because of that, the correct answer has got to be C. They will move away from each other. Okay, question 7. The speed of sound in air depends on the temperature of the air. Sound travels faster in warmer air and slower in cooler air. During the day, the ground is warmed by the sun and the air just above the ground is warmer. Okay, so here's the ground and the air here is warmer than the air higher up. In this situation, sound waves can curve upwards, creating sound shadows. How cool, where sounds are not heard by listeners on the ground. And this is an example of the wave actually changing its direction, the sort of the curving upwards, and this is an example of refraction. Anytime we have a change of direction, we're talking about refraction. Okay, next one. Stopping distance is the sum of the thinking distance and the braking distance. Which of the following changes gives the longest stopping distance of a vehicle being driven along a straight road and coming to a stop with a constant deceleration using just the vehicle brakes? Okay, so we have doubling the initial speed of the vehicle, the mass of the vehicle, the reaction time of the driver, or halving the brake force. Now, the answer is A, and let me explain why. Actually, the distance that you travel is proportional to the square of the speed, and if you use the Suvat equations, you can prove that. So there's an equation in physics which links the final speed to the distance with a constant acceleration. So this here is the final speed and this here is the initial speed. We don't normally do that at GCSE but at A level, but I would like to show you where this comes from. But you can see that V squared is proportional to S, and let's call S the stopping distance across here. So if you were to double it, then you would get a factor of 2V squared, meaning that S will increase by a factor of 4, which is really significant. So that's why when you become drivers, you should be very, very careful. Okay, question 9. We have a science experiment. An insulated block of metal is heated using an electric heater for 10 minutes. The mass of the block is 900 grams. The initial temperature of the block is measured to be 17. The final temperature is measured to be 43. The experiment is repeated using the same metal block and electric heater. This time the starting temperature is 19 degrees C and the block is heated for 15 minutes. The final temperature of the metal block in the second experiment will be approximately. Okay, well, they've given us quite a lot of information, but because everything is the same, the mass is the same, the block, i.e. the specific heat capacity of the block is the same, the only things that matter is the temperature. So here we're going from 17 to 43 in 10 minutes. So this means that we're gaining 43 minus 17 is 26. So that's 26 degrees in 10 minutes. So 26 divided by 10 means that we're gaining 2.6 degrees. Let me just write this a little bit more eligible. So 2.6 degrees per minute. Okay, well, if I repeat exactly the same thing for 15 minutes, I'm going to get 2.6 times 15. So let's put that into a calculator. 2.6 times 15 is equal to 39 degrees. However, my initial temperature is now 19, so it'll be 19 plus 39. This will be my final temperature, which is equal to 58 degrees C. Correct answer is C, like Celsius. Okay, question 10, the final question, the final multiple choice question. An experiment to investigate Boyle's law for a fixed mass of gas is trapped in a syringe at a constant temperature. The gas is slowly compressed, decreasing the volume of the trapped gas. After waiting a short time, the pressure of the gas is measured. The experiment is undertaken slowly, and there's a pause between compressing the gas and measuring the pressure because, well, anytime you're doing this experiment, the danger is that you compress the gas too quickly, and you guys might have probably have used a bicycle pump, and in a bicycle pump, notice that if you pump a little bit too quick, then the temperature rises, and exactly the same effect can happen here. So we have to do that experiment slowly. When we do that in the lab, the correct answer is B. Okay guys, hopefully you've enjoyed this, and what you need to revise next is electricity questions, because every year there's some electricity questions on this Olympiad, and have a look at these questions right over here.